2 now. We did example 1 in the previous video. So example 2 is identify as true or false and justify your answer. So the first one is a homogeneous equation is always consistent. That is true, right? So we'll put a T in front. So true, and the reason is that trivial solution is always present, okay? So the trivial solution is always the solution of the homogeneous equation, and hence it is always consistent. Second is the equation AX is equal to 0 gives an explicit description of its solution set. So actually this is also true. If you want to, get the reason, see page 47. It says, so look in page 47. In the middle somewhere, it says the solution set of a homogeneous equation AX is equal to 0 can always be expressed explicitly as a linear combination of a set of vectors. So and the reason is that when we have the non-trivial solution for the homogeneous equation, that will occur when we have at least one free variable. So it means if we have 3 variables, x1, x2, x3, and x3 is the free variable, we can always write x1 equals like ax3 and x2 equals bx3. So you see these are explicit equations because we have no x1 on the right side here in the first equation and no x2 on the right side of this equation. So that's why this is the solution is explicit. Okay. Next one is saying number 3 that the equation AX is equal to 0 has the trivial solution if and only if the equation has one free variable. Of course, this is false because we just mentioned in the if there is a free variable, then the solution is not trivial. Then we have actually infinitely many solutions. Number 4, the equation x is equal to b plus tv denotes a line through v parallel to p. So this is wrong because it denotes a line through p parallel to v. Okay. Number 5, the solution set of AX is equal to B is the set of all solutions of the form W is equal to P plus TV, where TVH. Oh, okay, P plus VH. Okay, there is no T. They didn't mention any T here. Where VH, this is a typo. It should be VH. Where VH is the solution of the equation AX is equal to 0. So this is not correct, because it should have been W is equal to P plus P plus T VH. Okay, so that's the mistake, so it is false. Number 6, if x is a non-trivial solution of AX is equal to 0, then every entry in x is 0. This is again false because if it is a non-trivial, then it has to have at least one entry non-zero. If it's all entries are 0, then that is the trivial solution. So this is false. Number 7, the effect of adding p to a vector is to move the vector in a direction parallel to p. Okay, let's see what this is saying. Let's say we have a vector p going in this direction, and then we have another vector v going like this. So adding p to a vector, so if I add p here, so I can add it like here, and find the Okay, let me make it a little bit different exam. I think it will be more clear like this. So this is my V, and let's say this is the P. So when we add V to P, what do we get? We get a vector in the middle if we can complete the parallelogram. Sorry, it's not that neat. Try it one more time. Maybe use another color. Okay, V parallel to V and then parallel to P. Yeah. So this is our V plus P. But note here, this is the point for end point of V plus P. So this is the end point for V, that is the end point for V plus P. So the question, the statement is saying, where did it go? Okay, the effect of adding P to a vector is to move the vector in a direction parallel to P. So can you see that's what we are kind of seeing, that V has been moved parallel to P. So we are, this is where we were, and now we are here. So we moved parallel to P, and it came here. So yes, this is true. Eighth, the equation Ax is equal to B is homogeneous if the zero vector is a solution. This is false, because the homogeneous if Ax is equal to 0. That's when it is homogeneous. It has nothing to do with the solution. If Ax is equal to B is consistent, then the solution set of Ax is equal to B is obtained by translating the solution set of Ax is equal to 0. That is correct. If you recall in the previous example, I think, before example 1 I explained, and in example 1 I explained. So the V is on the line that contains the solutions of Ax is equal to 0, the homogeneous equation, and the line which is parallel to this passes through P. That is the equation, and that is the line that contains all the solution sets of the equation Ax is equal to B. And so it looks like we translated it, we shifted it in that direction. So this is true. Okay, so now looking at example 3, this is something I will do later once we have introduced the notation, what this thing is, A to the T. Maybe some of you already know it, but hold on to it. So we will do this number 3 maybe somewhere when we are doing chapter 2, and then let's look at example 4 and 5. In the next video.